So welcome. This is Cambridge IGCSE International Mathematics, October-November 2020, paper 63, Investigation and Modeling. The first question, areas of the polygons inside and outside of a circle, 30 marks. This investigation looks the areas of the polygon drawn inside and outside of a circle of radius 10 centimeters. An inscribed polygon is a polygon in which all the vertices lie on a circle. This is an inscribed square. The circumscribed polygon is a polygon in which each side is a tangent. If at all each side is a tangent, it is called as a circumscribed polygon and inscribed polygon. So these are the two differences. You may find some of these formulas useful. Area of the circle has been given, area of the triangle has been given, sine theta, cos theta, and tan theta. Now, in 1a, the square circumscribes a circle, center O, radius 10 centimeters. Work out the area of the square. Now, this is 10 centimeters, so this also has to be 10 centimeters. So total has to be 20 centimeters. Area of the square will be 20 square, which is 400. Next, a square is inscribed in a circle of radius 10 centimeters. What is the area of the square? Now that's going to be 10. So what am I going to do with it? This is also going to be 10. So half base times height. 10 times 10. 100 by 10 is nothing but 50. But there are 4 such triangles. 50 times 4 is nothing but how much? 200. That's going to be the area of the square. Show that the area of the circle of radius 10 centimeters is 100 pi centimeters square. So area of a circle formula is pi r square, pi times 10 square, which is 100 pi centimeters square. Area of the inscribed square is less than the area of the circle is less than the area of the circumscribed square. So area of the inscribed square. Area of the inscribed square is nothing but how much? He's telling use this statement to complete the inequality below. Area of the circle, we got it as 100 pi. Area of the circumscribed circle. Circumscribed circle is 400. Area of the inscribed square is nothing but what? 200. So now what we can do it out? We can cancel 0 zeros, 0 zeros. So what do I get it out? 2 is less than pi is less than 4. Now, a regular hexagon is inscribed in a circle of center O and radius 10. Find the area of the regular hexagon. He's asking us to find it out the area of the regular hexagon. So what am I going to do? I'm going to join over here. Hexagon, each angle will be 60 degrees. So area of the hexagon will be half times 10 times 10 times sine 60. But how many such hexagons are there? 6 hexagons are there. Multiply it out. You should be able to get the answer as 260. Next, the equilateral triangle has a height 10 centimeters square. Find the area of the triangle. So the triangle area has been asked. Now he's asking us to find the area. So this angle is theta, which is 60 degrees. This is side A upon 2 or A. So then I know the height is nothing but what? 10 centimeters. So what am I going to do it out? I'm going to find it out tan 60. Tan 60 equals to opposite side 10 upon A. So A equals to 10 upon tan 60. So that is 10 upon root 3. That is the side. But this also will be A. So the total side of the equilateral triangle will be 2A. So 20 upon root 3. Now what is he asking? What is the area of a triangle? Area of a triangle is nothing but half base into height. Half base is 20 upon root 3 times height is 10 upon root 3. So it becomes 200 upon 6. So we can take a calculator and find the value of 200 divided by 6. When I find that one, 200 divided by 6, it should be giving me the answer as 33.3. But the height should be taken as 10, not 10 root 3. Height should be taken as 10. So what should be the area now? 200 upon 2 root 3. That's going to be the area. 200 divided by 2 square root 3. It's going to be 57.73 or 57.7. The height is 10, not 10 upon root 3. Now, a regular hexagon circumscribes a circle of center O and radius 10. Use your answer in part 1 to find the area of the hexagon. So we can see that what is happening over here. This is an equilateral triangle with a height 10. So area was nothing but what? 57.7. So there are six such triangles. So therefore, it's going to be 6 times 57.7. So what am I going to do? 57.7 times 6. So I take the calculator and multiply 57.7 times 6. It should be giving me 346.2 or 346, three significant figures. So it is 346. Used in question 1C, 2A and 2B2 to complete the inequality. 1C, 2A and 2B. So 1C. Where was 1C? Area of the circle is 100 pi. Is it the radius is 100 pi, right? Area of the circle was 100 pi. 1C is 100 pi. 2A. What was 2A? 2A was 260. And 2B2. 2B2 was 346. 346. So what does that becomes now? 260 is less than 100 pi is less than 346. So divide by 100, 2.60 is less than pi is less than 3.46. Give a geometric reason why the range in the inequality in question 2C1 is smaller than the range in the inequality 1D. So pi lies between 2.6 and 3.46, whereas in 1D what we got it out, pi lies between 2 and 4. What is the reason? Because this was a wide range. Basically pi value is 3.14. So when I say 2.46 to 3.46, that makes more sense. The reason is nothing but what? Because we are considering hexagons. So when we are considering hexagons, more approximation is possible. So as area of hexagon are closer to area of the circle. Area of a square is not closer because you can see that in hexagon only small parts are being neglected, whereas if at all I take a square, a larger part is missing. So therefore area of a hexagon is equals to area of a square. Now 3a. A regular 12-sided polygon is inscribed in a circle with center O and radius 10 centimeters. Find the area of this polygon. So what am I going to do it out? It is 10, and what is this one? 12-sided polygon. So angle at the center is going to be 360 degrees. 360 divided by 12. So what am I going to do? 360 divided by 12 is going to be 30. So each angle is going to be 30. Now I want to find the area of that particular triangle. Half times 10 times 10 times sine 30, which is 25. But there are how many such triangles are there? 12 such triangles will be there, times 12. So what is that is going to be 25 times 12, which is 300. So area of the polygon will be equals to nothing but how much? 300. Now a regular 12-sided polygon subscribes an circle of center and radius 10 centimeters. Find the area of this polygon. So therefore what am I going to do? I am going to draw this one. Now this is A. This angle is 30 degrees. So this angle has to be 15. This small angle has to be 15 degrees. So what am I going to do with that? For 15 degrees, A is the opposite side and 10 is the adjacent side. So I am going to use tan 15. Tan 15 is A upon 10. Tan 15 is A upon 10. So A is equals to tan 15 times 10. That is the side. But there is 2. Because it is A, this also will be A. So the total side will be 2A. So now area of the triangle will be half times 2 times 10 times tan 15 times height. Height is 10. Half times base times height. Base is 2 times 10 times tan 15 and height is nothing but what, 10. And again, how many such triangles will be there? There will be nothing but what, 12 such triangles. So times 12. So therefore, what does that becomes now? When I simplify it out, it becomes 2 and 2 gets cancels, 10 times tan 15 times 120. So it should be giving me 321.5 or 322. That's going to be the area. Now use your answer in part A and part B to complete the statement. So area of the circle was nothing but what again, 100 pi. This is nothing but what, 322, and this was 300. So divided by 100, 3 pi and 3.22. So see, we can get it out much more closer to the value of pi. Show that the formula for the area a centimeter square of a regular polygon with n sides inscribed in a circle of radius 10 centimeters is going to be, this is going to be the area. He's asking us to prove that area of a regular polygon. So if we have seen that, we can see that area of one triangle, when we are finding it out area of one triangle, we were doing it out half times 2 times the 10 times tan of 15. What is this 15? Tan 15 times 10 times 12, but he is asking us to find it out in the form of sine. So first of all, we have to find the area of a triangle in the form of a sine. So area of a regular polygon with n sides inscribed in a circle. The polygon is inscribed in a circle, so we have to consider this particular thing. Polygon is inscribed in a circle. So what is the formula? Half times 10 times 10 times sine 30. From 30, from where I got it out, I got 360 by 12. If there are n sides, it should have been 360 by n. So area of such polygon will be nothing but what? Half times 10 times 10 times sine 360 upon n. That is for one triangle, but there are n such triangles, right? So multiply with n. So it becomes 50n sine of 360 upon n. This is the area of the polygon with n sides inscribed in the circle. Show that the formula for area b centimeter square, the regular polygon with n sides that circumscribe the circle of radius 10. So for that, we are going to take it out this one. We can see that it is half times 2 times 10 times tan 15. From where I got it out 15, I got it out 360 divided by n, and also again 2, we are dividing into two parts. One part is over here, one part is over here. So 360 by 2n times again nothing but how much? 10. So area of one triangle will be half times 2 times 10 times tan 360 by 2n. Again another one more 10. So what does it becomes? 2 gets cancels. It becomes 100 tan 180 by n. That's going to be the answer. Work out the area of the regular polygon with 100 sides, that is inscribed in a circle of radius 10 centimeters. So it is 50 times 100 times sine 360 upon 100. Simplify that, 314.0. Work out the area of a regular polygon with 100 sides circumscribe the circle. It will be 100 times tan 180 upon 100. Simplify by calculator, you should be getting it out 314.3. Use your answers in part B to explain how could you find the value of what is this pi correct to three significant figures. So we can say that pi lies between 314 and 314.3, 100 pi. So divide by 100, 3.14 pi 3.143. We can see that pi lies between 3.14 and 3.143. That's going to be the explanation. Coming to part B, modeling questions 5 to 8, modeling containers. Now Olivia wants to design a closed container of volume 1000 centimeter cube and a minimum surface area. So it should be volume of 1000 centimeter cube and a minimum surface area. Olivia uses square based cuboid to model the container. Write down the formula for the volume. So volume is nothing but what? Base area times height h. Find the formula for the surface area S of the cuboid in terms of x and h. Give your answers in the simplest form. S equals to How many base is x square and top is also x square, whereas left is xh, right is xh, and front is xh and back is xh. So there are four sides. So it's going to be 4x square plus 2x square plus 4xh. This is for top and bottom, and this is for left, right, front, and back. Four sides. V equals to 100. Find right h in terms of x. V equals to 1000. So 1000 equals to nothing but how much? X square h. So h equals to 1000 upon x square. Show that s is equal to 2x square plus 4000 upon x. So x is equals to nothing but what? 2x square plus 4x times h. H is nothing but what? 1000 upon x square. Simplify that. You should be getting it at 2x square plus 4000 upon x. That is the surface area. Work out the value of s when x equals to 25. So plug in x equals to 25. So it becomes 2 times 25 square plus 4000 divided by 25. Simplify, you should be getting it at 1410. Sketch the graph of s is equal to 2x square plus 400 upon x. So what you can do it is you can use a graphing calculator and sketch this graph and see that the limits of x should be between 0 to 25. So what is that? So enter into the graphing calculator 2x square plus 4000 divided by x. Then keep the values of x between 0 to 25. And then also y values should be between no values for y, so starting value will be 0. 0 and maximum value you can keep it as at random, maybe 100. Then you should be able to get a graph for 2x square plus 400 upon x and only positive x values. So what am I going to do with that? When I do by graphing calculator, it is taking time to load. So I change the limits of x from 0 to 25. So it is approximately in this shape. Next, find the minimum surface area of the cuboid. So what is he asking us to find it out? Find the minimum surface area of the cuboid. So for that, minimum surface area. So how should I be able to get it out? Minimum surface area. The minimum surface area is going to be nothing but how much? 600. For this, what we can do it out, the exact point from the calculator, you can check that the minimum point of this curve should be about 600. Describe the container that gives the minimum describe the container that gives the minimum surface area for Oliva's model. So what is it? Surface area has to be nothing but what? 600. So when it can be a 600 minimum surface area, you can see that it is only has to be a cube. A cuboid cannot give a minimum surface area. A cube can give you a minimum surface area. And the side should be, when you see from the calculator, this value, the side should be equals to nothing but how much? 10. Side of 10 centimeters. The minimum value from the graphing calculator will give you a 10 comma 600. So minimum surface area is 600 and it is occurring at 10. So it should be a cube of side 10 centimeters. Next, the volume of the container of radius, volume of a cylinder of radius r and height h is given. The curved surface area is given by 2 pi r h. The total area of the surface of this model is T. Volume equals to 1000. Show that T equals to 2 pi r square plus 2000 upon r. So basically total surface area is 2 pi r square, top circle plus bottom circle plus what is this? The curved surface area. What is the curved surface area? 2 pi r h. And he gave that volume equals to 1000. So volume equals to 1000. So 1000 equals to nothing but what? Pi r square h. So from there, I will be getting the value of h. H is 1000 upon pi r square. So plug in over there, it becomes 2 pi r square plus 2 pi r h. 2 pi r h is nothing but what? 1000 upon pi r square. So which will be giving me that thing but answer 2 pi r square plus 2000 upon r. Find the minimum surface area of the cylinder. So for this one, what should I be doing it out? I should be able to, what is this? Sketch the graph. When I sketch the graph, I will be getting it out in this way. And you can see that the minimum area is at 545.54. From the graphing calculator, the minimum point occurs at 554. Find the dimensions of the cylinder with the minimum surface area. For this, what am I going to do it out? It is going to be R and this is going to be S. So from the calculator, you should be able to get the value of R as 5.42. Now plug in this value of R as 5.42 in this H. So H equals to 1000 upon pi r square, pi r square. Simplify that, you should be getting the value of H as 10.48, 10.8. Next, question number 7. Volume V of a pyramid, base area A and height h is given by volume equal to 1 upon 3 AH. The pyramid OABCD has a square base of side x centimeters and height h centimeters. The vertex O of the pyramid is directly above the center of the square. E is the midpoint of BC. Find an expression of OE in terms of h and x. So I'm going to construct a right angle triangle. So this side has to be x upon 2. So OE square equals to x upon 2 whole square plus h square. So OE equals to square root of x square upon 4 plus h square. Now B. The total surface area of the model P is P centimeter square. Volume equals to 100. Then show that P equals to this much. So what am I going to do that? Volume. So volume is nothing but what? 1 upon 3 AH. So volume is nothing but what? 1000 equals to 1 upon 3 AH. Area, total surface area AH. So from there, area of the base is nothing but x square times h. So from there, h equals to nothing but how much do I get? 3000 upon x square. This is the value of h. Now total surface area. What is the total surface area? P equals to base area plus there are 4 triangles and each triangle is half times base times height. Height is nothing but what? OE. So it becomes x square plus 2 times x times OE. OE is nothing but what? X square upon 4 plus h square. H square is 3000 upon x square. So upon x power 4. So now further simplify this one. So it becomes x square plus 2x square root of x power 6 plus 36. 9 times 4 is 36 followed by 6 zeros divided by square root of 4x to the power of 4. So it becomes x square plus 2x times square root of x power 6 plus 36 followed by 6 zeros divided by 2x square. Simplify that, it becomes x square plus square root of x power 6 plus 36 divided by x. That's going to be the answer. Find the minimum surface area. So for that, what again? You have to draw the graph. When you draw the graph between x and surface area P, you are going to get it out a curve like this. Find the minimum point. Minimum points occurs at 660. Now, at the x value, what is from the calculator? It is 12.8. Plug in this x value to get the value of h. H equals to 3000 divided by 12.8 whole square, which gives you 18.2. Now, Olivia recommends a container with the smallest surface area to the company. Give a geometric reason why the company might not accept Olivia's recommendation. So she would have been recommending it out all the way. She is doing it out cylinder. She would have been recommending it out cylinder. So, so what is happening? Why it is not in proper shape? Because we can see that the exactly there would have been a lot of wastage in the extra part. Lots of wastage in the extra part. So therefore, if at all we use the cylinder, she tried with the pyramid, then she tried with the cylinder, and she saw that cylinder would have been better, but is to cut the cylinder into that particular shape, there should have been a lot, because whenever we are cutting into a circle and so on, there will be a lot of wastage of the paper. So therefore, what we can do it out is we can write the explanation as a lot of wastage in the extra part. That's going to be the answer. So that completes the paper. See you in the next paper. Bye.